I can come give you a key. So I guess give me just 1 second. All right, lads and ladies, good morning. Welcome back to College Algebra. Today is our last day of class. We've got the last midterm coming up. That's going to be on Thursday, but today is our kind of last opportunity to sneak in any bits of review or anything like that that you guys want to talk about. So let me go ahead and get the dot cam set up. Here we go. All righty. You guys don't need to worry about areas between curves, not just yet. Today will be our little review day. So I want to start with making sure we're all aware, comfortable, familiar with the timeline. Let's get the title card up. This is MAC 1105, section 015, which is a college algebra class. And today is the 19th of April, 2022. All right. So the plan for today is just to do kind of whatever you guys want to do. We can look at homework problems, quiz problems, whatever you feel. And it can be stuff that you want to look at in preparation for exam 3 or stuff you want to look at in preparation for the final. Totally up to you. Before we get into it though, quick reminders. Exam 3, our last midterm exam, is this Thursday, which is the 21st. And I unlocked the review quiz for you, or it wasn't locked before, but I adjusted the due date for the review quiz to the 21st. So please definitely work the review for exam 3, the review quiz in my open math. The other date I want to remind you of course, is the date of the final. If you have not yet put this in your calendar, please do so. The final exam is the 26th at 10:30. The 26th, I think, is a Tuesday. Yep. And both of these tests will be conducted the same way all of our other tests have been done, that you'll join a Zoom meeting just like this one from your phone. You will log into Canvas, navigate through HonorLock, take the test in my open math. And as soon as you finish the test, you're going to scan and upload your written work for any problems so I can go through and assign partial credit. All right, the rest of the class is yours. What would you guys like to do? We can look at systems of inequalities. We can look at logarithms, exponentials. We can look at anything you guys would like to look at. Totally your call. So you can let me know in the chat if you want to look at just a certain problem type or a specific problem from the homework or any of the past quizzes, anything like that. Just go ahead and let me know.
Can you go back over the concept of like the f of x, like the input of the g of x? Kind of forgot about.
Sure, yeah, the composite.
Can you do an example for the f of x and the g, like finding both of them? Because I kind of got confused.
Sure, let's do it. All right, and again, just go ahead and, while we're doing this, go ahead and look through past stuff, you know, hit the chat with whatever it is you want to see. So let's say f of x is maybe 1 over x plus 1. And g of x is something like x squared minus 2. And we can find f of g and g of f and their domains. So I think the domain question here is often a challenge when it comes to these composite functions. So let's first look at how we find formulas for these functions, and then separate from that, we'll look and see how to find the domain for each of those functions. While we do that, we'll kind of remind ourselves the domain rules. Is this the sort of thing you were talking about, Tyson? Does this look good?
Yes, sir. And then could you go over an example of like one in the table too? Because
Sure.
those kind of confuse me too.
Yeah, approaching these sort of problems from tables can be a little bit tricky. So, all right, let's do it. So first, f of g. If I want to find f of g of x, what's the very first step? You guys remember way back when we were talking about this stuff, we kind of, for this whole section, we had like a first step that'll kind of push us in the right direction. And from there, we can usually sort of smell where to go. What's the first step for finding a formula for something like this? So I don't mind saying the first step here is to use the definition. We always begin with the definition. So if you're given some sort of weird operator like this, like f times g of x, or f of g of x, or f plus g of x, very first thing you want to do is take it from that notation into the notation that we're a little more familiar with. And then from here, we kind of know what this means. This means we're going to take g of x and plug it into f of x. So that's what this really says. This says you're going to take g of x and use that as the input for f. So I would write this as f of, and then what is g of x? We work from the inside out. G of x is x squared minus 2. And kind of remember the silly game we play here. F of x is 1 over x plus 1. F of poop would be 1 over poop plus 1. F of your mom would be 1 over your mom plus 1. So f of x squared minus 2 would be 1 over x squared minus 2 plus 1. This is kind of the magic step. And getting comfortable with this idea, I know these things seem silly, but it really is a useful way to think of stuff. That's really what this notation f of x means. When you're given a formula for f of x, it means you want to find the output associated with any input, however ridiculous that input is. You just replace x in the formula by that input. And here, the input is x squared minus 2. The formula is 1 over x plus 1. So we replace this symbol by x squared minus 2. And it's usually wise to do this in parentheses. For this particular problem, it doesn't matter. But in general, that's the procedure. Before I try to find the domain, let's simplify this a little bit. X squared minus 2 plus 1, that's the same as x squared minus 1. And this is kind of a nifty connection to rational functions now also. So this composite function happens to be a rational function. Does anybody remember how to find domains of functions like these? can anybody remind me those domain red flags, right? Like you go on a date with somebody and they're like, I really hate my parents, fucking red flag. Well, watch out, right? Functions have those too. This thing doesn't hate its mom or anything like that, but we want to figure out what sort of things could trigger this function, right? What sort of stuff do we need to stay away from when dealing with this function? Those are the domain red flags. So in general, what domain red flags have we talked about this semester? Well, I'll get started here. How about variables under square roots? Right, we know that's a problem. If there's a variable under a square root, you need to make sure that the inside is greater than or equal to 0. And the other big domain red flag that's been with us all semester is variables in a denominator. And there we need to make sure that the bottom is non-zero. These were the two big ones that were with us through the whole semester. And you definitely want to commit these to memory, right? Variables in the denominator, making sure the bottom is in 0. You can't divide by 0, right? This is a rule of arithmetic that we've known forever and ever. You cannot divide by 0. So we need to make sure if we have a function where there are variables in the denominator downstairs in a fraction, that we stay away from any values of the variable that would make this downstairs equal to 0, because the bottom is not allowed to be 0. And similarly, if you try to take the square root of a negative number, we run into trouble. So if you have variables under a square root, you got to make sure that the inside of that root is greater than or equal to 0. There was a third one that we learned when talking about logarithms. We're over 3. Can anybody help me out with this last domain red flag? Hear Jeopardy music in your head. Variables inside logs. If you have a variable expression inside a log, remember you cannot take the logarithm of a negative number or 0. So here you need to make sure that the inside is strictly greater than 0. These are our domain rules. Right? This is everything you need to know to find the domain of a function. This function, 1 over x squared minus 1, has one of these. It has variables in the denominator. So we need to make sure that the bottom is not equal to 0. So to do that, we're going to figure out what does make the bottom 0, and then we will exclude those from the domain. So there's a bunch of ways you could solve this. You can factor. This is x minus 1 times x plus 1 equals 0. So you get x equals 1, x equals negative 1. So those are the two numbers we need to stay away from. So the domain is, in words, all real numbers except x equals negative 1 and x equals positive 1. You could write this in the set builder notation as the set of all x, such that x is not equal to negative 1, x is not equal to positive 1. Or you could write this in interval notation as the set, oops, sorry, it's the interval negative infinity to negative 1, union with negative 1 to positive 1. union with positive 1 to infinity. So that's the first composite function and its domain. Is there any part of this that we want to look at a little more closely, or we want a reminder where it comes from, anything like that? Okay, then let's try to keep moving briskly here. We're going to find the other composite, and we'll look at a tabular problem really quick. The other composite was G circ f of x. Now we just went through this, so I really want some interaction. What's my first step? We just did this for the other one. Somebody tell me my first step. We always begin with what?
Definition.
Very good. So the definition of G circle f of x is G of f of x. And then we work from the inside out. So this is G of something. What's the something? Well, it's this thing, f of x. F of x is 1 over x plus 1. And then I ask, okay, well, G of, dog shit would be dog shit squared minus 2. G of your mom would be your mom squared minus 2. G of 1 over x plus 1 will be 1 over x plus 1 squared minus 2. And there's a bunch of other forms you could write this in, but this is fine. There's nothing wrong with this. This is correct. If you want to find the domain, same red flag. There is a fraction here, and in that fraction, there are variables in the bottom. So we need to make sure that the bottom of that fraction is non-zero. That means we figure out where x plus 1 is equal to 0. That's when x is -1. So the domain is, in words, all real numbers except x equals to -1. In set builder notation, that's the set of all x such that x is not equal to -1. And in interval notation, that's -infinity to -1, union with -1 to infinity. Okay, a quick example using tables. Let's find f of g of 2 and f of 1. And I'll make the tables here. F simple f of x and x. So for my inputs, let's use 0, 1, 2. And we can have associated outputs here being 2, 0, 1. And for g of x, we can begin to 1 and 2. Okay. 2 tables, 2 functions, 2 things to find. Let's start with f of g of 2. Again, you work from the inside out. right? I know I'm looking for f of something, but I can't answer the question until I know what that something is, and that something is g of 2. So I look over here to the table for g. On the x row, I go over to 2. Here's 2. So g of 2 is 1. So that means f of g of 2 is the same as f of 1. And f of 1, if we look at the table for f, come down here, let's see, here's the x row. If I come to 1, I see f of 1 is 0. So this is 0. We were also asked to find f of 1. And it's the same sort of thing. It just happens to be the same function in both composite spots. This means we want to find f of 1, the inside here, which we already did find, that's 0. So this is the same as f of 0. And then when we look at the table for f of 0 is 2. So f of 1 is 2. A few people said they wanted to find some inverse function stuff. So while we're here, let me add one more. How about g of f inverse of g of f inverse of 1? G of f inverse of how about g of f inverse of 2? And g inverse of g of 1. Why not? We can get some inverse functions in here as well. So here's the first part, here's the second part. If I want to find g of f inverse of 2, I first need to find what f inverse of 2 is. So can anybody explain to me how I find f inverse of 2? I don't have a table for f inverse, I just have a table for f.
The input and the outputs would be flipped, right?
Yeah, that's exactly correct.
So then that would mean
You got it. There's no harm in taking a guess. I can put some words here that might help. F inverse of 2 is the input that f sends to 2. So we're asking f of what is equal to 2?
oh, 0.
Yeah, exactly, 0, right? F of 0 is 2, so f inverse of 2 is 0. So working from the inside out, g of f inverse of 2 is the same as g of 0, because f inverse of 2 is 0. And then g of 0, if I look on the table for g of 0, if I come down here to the x column, when x is 0, g of x is also 0. So g of f inverse of 2, that's 0. All right, last one. G inverse of g of 1. I claim you don't even need the table. cover up the table for G. Yeah. I'm going to cover up the table for G. What is G inverse of G of 1? Don't overthink it. You plug a function into its inverse function, what happens?
Isn't it just the opposite of it?
It's true that the inverse function is the opposite of the original function. So if I take 1 and I do G to it, and then I do G inverse, which is the opposite of G to that, what should I get out? Think of the machine diagrams. Remember, the machine diagram for G inverse is the same as the machine diagram for G, just running backwards. So I'm going to take this number 1, I'm going to do some bullshit to it, and then I'm going to undo that bullshit. So I should get back should get back 1. Because in general, G inverse of G of anything will always just be that thing. And this is true in the other way as well. G of G inverse of anything will always just be that thing. The word I was looking for there is cancel, right? In a sense, G inverse and G, when you plug them into each other, they cancel, just like logs and exponentials or squares and square roots. If you do the inverse function, having already done the original function, you're going to get whatever you were plugging in. Right? So if I start with 1, I square it, and then I take a square root, or I start with 1, I exponentiate and then take a log. I start with 1, I cube it and then take a cube root. No matter what it is, as long as these guys are inverse functions, I'm going to get back 1. Okay, we can verify with the table as well. G of 1 is 2. Sorry, no, here it is. G of 1 is 2. And then if I want to apply G inverse to 2, I would ask what input gets sent to the output 2. So that's going to be G inverse of 2 is 1 again. You just go here to here, and then here back to here. All right. Let's move on. Let's see, chat some homework questions. Sort of general questions about half-life and stuff. Let me make sure I'm not missing anything at the top. So we'll do these in order. Homework 21, number 23. Okay. On the final exam for a creative course, Bean was required to write a combination of at least 10 poems or paragraphs. Bean, maybe Ben. Ben knew that each poem would take him 30 minutes to write, while a paragraph would only take 10 minutes. Ben was given 2 hours to complete the exam. Let Y be the number of poems, X be the number of paragraphs. Graph each inequality on a separate coordinate grid and shade the solution set for each. All right, I'm going to try to transcribe just the relevant information. So Ben needs to write at least 10 poems, and we're going to represent poems by Y, or paragraphs, which we'll represent by X. Poems take 30 minutes to write. And paragraphs take 10 minutes. And Ben has 2 hours. To finish. Okay, so we want to construct a system of inequalities here, 2 inequalities. Let's think this through for a second, make sure we understand what's being asked. Homeboy got to come up with 10 things, right? And that could be 5 poems and 5 paragraphs, or 3 poems and 7 paragraphs, or 10 poems and 0 paragraphs. But he needs to come up with 10 of these things. Some of them can be poems and some of them can be paragraphs. He could write 20 of each if he wanted to, but he needs to come up with at least 10. So something needs to be at least 10. That means we're going to have an inequality. Some bullshit over here is greater than or equal to 10. And the bullshit over here should be the total number of things he produces, right? He needs some combination of poems and paragraphs adding up to at least 10. Well, if he writes Y poems and X paragraphs, then how many things altogether has he written? This needs to be the number of poems plus the number of paragraphs. Right? The total number of things he produces has to be at least 10. And they said, let Y be the number of poems, let X be the number of paragraphs. So this means we need X plus Y to be greater than or equal to 10. This is our first inequality. The second part we need to think about maybe a little bit harder. This is a lot like those mixing problems, if you remember those from 1033, like you've got 20% acid solution and a 40% acid solution. You need to mix some amount of it to get a 70% acid solution. Not bullshit. It's the same sort of thing.
Isn't it 30x plus 10y is like greater than or equal to like 120?
Very
minutes.
close. Yeah, almost exactly correct. There's one tiny thing we gotta change.
Is it less than or equal to?
Yeah, that's it. So let me walk through that logic just to make sure what Lexi said there is perfect. Each poem takes 30 minutes. So the amount of time he spends writing poems is going to be 30 minutes times the number of poems he writes. So let me break this down into bits. The time writing poems, that's going to be 30 minutes times the number of poems he writes, which is Y. All right, if I write 2 poems, each one takes me 30 minutes, then that's 2 times 30 or 60 minutes. The time my dude's going to spend writing paragraphs, I don't know how many paragraphs he's going to write, but I know that if he writes X of them, and each one takes 10 minutes, then that's going to be 10 times X. And we know the dude only has 2 hours. The only thing we got to be careful about here, 2 hours is 120 minutes. Right? Because we're measuring the time for the poems and paragraphs themselves in minutes, we got to make sure that we're using the same units everywhere. And we want to finish before the test ends. So we want the total time. Right. Total time writing to be less than or equal to 2 hours or 120 minutes. And the total time writing is the time writing poems plus the time writing paragraphs. So we want that to be less than 120 minutes. Well, the time writing poems is 30y. Time writing paragraphs is 10x. So we need that to be less than 120 minutes. So this is your second inequality. And from here, this is the same sort of thing that we were doing, just graphing, shading the region. So our system, if we want to, oh, they didn't ask for the system, did they? What did they ask for? They asked you to sketch each one individually, right? So let me grab a fresh sheet over here. So are there any questions about how he came up with either of these boxed inequalities? Okay. So if I want to sketch this first inequality, x plus y is greater than or equal to 10. We're going to solve this for y, sketch the line. The line x plus y equals 10, which is the same as saying y equals 10 minus x. So that's a line whose y-intercept is 10. I'll just label this as 10. And its slope is -1. And I'm sketching it as a solid line because the inequality we have here is greater than or equal to, right? If it was strictly greater than, then I would sketch this as a dotted line. And really our inequality here, if we want to think this as the over and under approach, this is the same as saying y is greater than or equal to 10 minus x. So I'm interested in the y values that are above this line. Or you could test a point from the two regions, right? One line splits the plane into two regions, below and above. And you could test a point down here, like 0, 0. If you plug 0 and 0 in here, you get 0 is greater than or equal to 10. So that would not be a part of the solution. You could find this x-intercept. This is also 10 because the slope is -1. So you could try something like 10, 1, which would be up here. If you test that, if you plug in 10 and 1, you get 11 is greater than 10. So this is your solution region, either way you want to think of it. The other inequality we had was 30y plus 10x is less than or equal to 120. I would begin here by dividing through both sides by 10. Remember, you can do everything with inequalities that you do with equations. You just have to be careful. If you multiply and divide by a negative, the inequality flips over. So if I divide everything here by 10, this is going to become 3y plus x is greater than or equal to 12. And these are equivalent inequalities. They say the same thing. And then I can solve this for y. This is the same as saying 3y is greater than or equal to 12 minus x. And that's the same as saying y is greater than or equal to 4 minus 1/3 x. That last step there is just dividing everything by 3 or multiplying both sides by 1/3, however you want to think of it. So this is a line whose slope is -1/3 and whose y-intercept is +4. But this is supposed to be a less than or equal to, isn't it? Did I write this down wrong? I did, I'm sorry. This is less than or equal to everywhere. So y-intercept 4, it's 4, slope -1/3. So it's going to be a shallow but negative slope. Something like that. And I want all the y values that are smaller than the y values on this line. So I'll shade everything underneath. Or again, you can test points. If I plug in the origin 0, 0, then I get 0 is less than or equal to 4, which is a true statement. So this would be my solution region. And if you wanted to solve the whole system, if you wanted to see the solution to both inequalities at once, you would sketch both of these in the same plane. Did the problem ask us to do that or just separately? Just separately. Okay. So that was 21, question 23. We wanted to look at some half-life stuff and some inverse function stuff. I think that's a good idea. And then we'll look at some of the 27 through 30 from homework 21. It's been a while since we talked about half-life. So what do we want to do here? Let's say scientists find, I don't know, dinosaur bone. To have, let's say 7% of the carbon-14 found in living tissue. If the half-life of carbon-14 is 5,700 years, how old is the bone? Now I'm spitballing numbers here. This could come out very unrealistic. But the problem setup is a classic one. You know the half-life of something, you know what percentage of it remains, so find the age. We have to begin with our half-life function, which we've been writing as f of x equals c times 1/2 to the x over k. C is the initial amount. K is the half-life. These are both constants. And x is the variable representing time. And it's being measured here in years. I don't know what the initial amount of carbon-14 in the bone was. I do not know what C is. But that's not going to be a problem. We'll still be able to solve this. I do know what K is. They told me that the half-life of carbon-14 is 5,700 years. So this is the same as saying f of x equals c times 1/2 raised to the x divided by 5,700. If there was initially 100 grams of carbon-14 in this bone, and there's only 7% now, then there would be 7 grams left. If there were C grams of carbon-14 in the bone initially, then there would be 7% of C grams left. So since 7% remains, and originally there were C, let's say grams, we know they're currently 7% of C, right, of carbon-14. And that 7% of C, that's 0.07 times C. Right, that's how you calculate a percentage of something. You write that percentage as a decimal, and then you multiply that times the thing you're taking that percentage of. Therefore, we need to solve I'm trying to solve for a time, so I'm trying to solve for X. I know right now, this is how much shit there is. I know that after X years, this is how much shit there is. So I should set those things equal to each other. I need to solve the equation C times 1/2 to the X over 5,700 is equal to 0.07 times C. So this is the equation we need to solve. This will tell us how long it's been since the dinosaur died. And the reason we can get away without knowing this constant C is because when we go to solve this equation, our very first step is dividing both sides by C, and the C's cancel. So that will give me 1/2 to the X over 5,700. 0.07. And when we first started doing these problems, at this point, we would have to turn to our calculator and do the whole graph table thing. But we've got logarithms now. So how do I solve this equation without fucking around in the table? I will go ahead and boot up Labit. What kind of equation is this? So linear equation, quadratic equation, rational equation, logarithmic equation, the moment equation. Some exponential equation, right? Because my variable is here in this exponent. So we should solve it with logarithms. To get the variable x down out of the exponent, where I can, do shit with it, solve for it, I need to take some logarithm. And when we do that, we need to take the log of both sides. Remember, I always use the natural logarithm here. So I'll take the ln of both sides. That means we're going to shove both sides inside the natural log. And then I have a rule for logarithms that says if you have a log of something raised to a power, you can bring that power down in front. This will give me x over 5,700 times the natural log of 1/2 is equal to the natural log of 0.07. We can then multiply both sides by 5,700. And then divide both sides by the natural log of 1/2. And that's your exact answer in terms of logarithms. Remember, this is going to be on exam 3, right? Exponentials, logs, and systems. That's what exam 3 covers. So make sure you practice the log and exponential stuff. If there's one part of this course that that really deserves your full attention, it is this part. If we want to approximate this as a decimal, we can by using our calculator. This is one of the reasons why we choose to use the natural log, because your calculator has a natural log button. So I'll type 5,700 times the natural log of 0.07. I'll go ahead and hit enter here. That's my numerator. And then I'm going to divide that by the natural log of 1/2. And I get 21868.06. Okay, so like I said, I made these numbers up. Obviously, there are no 20,000-year-old dinosaur bones. They're all much, much older. But this is the procedure. And there's many half-life problems that go this way. So I think it's worthwhile to take a second here. Are there any questions about what we set up, how we set it up, how we solved? Okay. We wanted to take another look at inverse functions. We already looked a little bit at inverse functions through a table, but let's do a problem where we solve explicitly for an inverse function. Let's find the inverse to each 1-to-1 function below. And say f of x is about x cubed plus 1. G of x would be 1 over x minus 1, and h of x would be x plus 2 over 3x minus 1. I've told you that these functions are 1-to-1, but somebody remind me, how do I check if a function is 1-to-1? What's the fast way to see? Like if I don't know that this function is 1-to-1, how can I check real quick? Something to do with this device. There was a test, remember? It's called the horizontal line test. So if I wanted to check that this is indeed a 1-to-1 function, I can take a look at the graph, x cubed minus 1, and ask, does this pass the horizontal line test? Are there any horizontal lines that hit this thing more than once? There are not. Therefore, this thing is 1-to-1. So remember, you can always check this with the horizontal line. But if I just want to find the inverse, we have a procedure. First, we write y in place of f of x. Then we try to solve for x. This was like our step 1. And this was like our step 2. Our step 3 was to swap x and y, and you should do that after solving for x. So first, plug in y for f of x, then solve for x, then swap x and y. So I can write the cube root of x plus 1 plus y. And then finally, after you swap x and y, you can write f inverse for y. So this will be the cube root of x plus 1 equals f inverse of x. And that's your inverse function. We can try this for the function g. First, I'll write y equals 1 over x minus 1. I want to solve this for x. This is a little trickier. All right, we're going to hold here until somebody can give me a nudge or a hint. I know we're trying to move quickly, but I also want to make sure we get a little interaction. So how could I solve this for x? What would be a good first step in solving this for x?
Would you multiply both sides by x minus 1?
Perfect. Yeah, that's exactly what I'm looking for. So if I multiply both sides by x minus 1, then I'll get parentheses x minus 1, close parentheses, times y equals 1, right? Multiply on this side by x minus 1, the x minus 1 factors cancel, and you just get 1. Multiply this side by x minus 1, you get x minus 1 times y. That's perfect. What now? I want to get x alone. If you think about what's keeping x from being alone, there's two things, right? There's a minus 1 here, and that's inside the parentheses. And then there's this times y here. So we got to get rid of the y first. So I can divide both sides by y. And then I can add 1 to both sides. This is my step 1. All of this is my step 2. Now that I've solved for x, I can swap x and y. And then finally, I can write g inverse of x for y. A little note, we could have gone from here to here, or something like that, by flipping both sides also. That's a valid operation. You can take reciprocals on both sides. But this way of doing it, multiplying both sides by x minus 1, I think that's actually the smarter way to go, because that sort of thing is what we're going to need here. So flipping both sides would not help us with this last one. So let's keep that in mind as we try to find the inverse of the function h here. So I'll write y equals x plus 2 over 3x minus 1. Now I want to try to solve for x. And the idea is the same as this guy. We want to get rid of this denominator. So I'll multiply both sides by 3x minus 1. That'll give give me parentheses 3x minus 1 close paren times y equals x plus 2. Again, the goal is to solve for x. I've got an x here, but now I also have an x over here. So dividing by y at this stage wouldn't help me because that's going to give me an x plus 2 over y, and I want to get this x together with this x. So instead, from here, we're going to distribute. I get 3xy minus y equals x plus 2. And now every term that has an x comes to the left. Every term that doesn't have an x goes to the right. So first, let me bring the minus y over to the other side. So I have 3xy equals x plus 2 plus y, adding y to both sides. So now there are no terms on the left without an x, but there is a term on the right with an x. So I need to bring this over here. 3xy minus x equals 2 plus y. So now we've accomplished what I said. Right? We want to get every term that has an x on the left and every term that doesn't have an x on the right. The reason we do that is so we can factor out an x. If I factor this x out, I'll have 3y minus 1. And on the right-hand side, I still just have 2 plus y. Not doing anything there. Now, finally, I'm trying to get x alone. I've got x times some bullshit. So let's divide by the bullshit. And I get x equals 2 plus y over 3y minus 1. Oh, and totally on accident, I've conjured a function that is its own inverse. So not a thought. So lastly, we can swap x and y. And then finally, we can write h inverse for y. And something kind of cool did happen here. The inverse function is 2 plus x, or x plus 2, over 3x minus 1. The original function is x plus 2 over 3x minus 1. This function is its own inverse. That's actually kind of rare, and functions like that are called involutions, but you definitely don't need to do that. Just a neat fact. All right, we just found 3 inverse functions. The procedure is always the same. Any questions on what we did here, how we did it, why we did it? Okay, I think we have time to look at maybe one of 27 through 30. That was the last thing that was requested. Any strong feelings about which one of these we would do? $29? Okay. They tell us company, the Shredder Inc. produces 2 types of paper shredders, home shredders and office shredders. The office model requires 5 hours to put together and 8 hours of finishing work, and 8 finishing work units for finishing work. 8 finishing work units for finishing work. The home model requires 2 hours to assemble and 4 finishing work units for finishing. The maximum number of assembly hours is 50 hours per day. the maximum number of finishing hours available is 29 units, 29 per day. So I think one of the problems here is that the language is very verbose. 8 finishing work units, think of those as finishing hours, right? I think this is the man who typeset these is a Frenchman, and I think perhaps his use of the English language here is a little awkward. Well, let me try to transcribe the important information. 2 shredders, home and office. We'll let X be the number of office shredders and Y be the number of home shredders. Y is the number of home shredders. The office model takes 5 hours to put together and 8 hours of finishing. Five hours of assembly and 8 hours of finishing, whatever the hell that means. And the home model requires 2 hours assembly. I don't know what kind of really complicated paper shredders we're talking about here, but okay. 2 hours assembly and 4 hours of finishing. All right. They tell us that the maximum number of hours available to build shredders is 50 per day. I guess these are man hours. There aren't 50 hours in a day. But max assembly hours is 50. And the max finishing hours is 92. So they want a system of inequalities, which will describe the number of shredders of each type that can be produced. The idea is to take the assembly information and combine that into one inequality, and take the finishing information and combine that into one inequality. So if I make X office things and Y home things, then the total assembly time is going to be 5 hours for each of the office shredders. That's 5x plus 2 hours for each of the home shredders. That's plus 2y. And I only have 50 hours of work that people can put into these things per day. So this needs to be no larger than 50. I know there's 24 hours in a day, but the idea is maybe you got 50 people or 20 people working for you. Together, they can each put in 1 hour per thing or whatever. You can sum to more than 50. If you have 2 people working for 12 hours in a day, that's 24 man hours. If you have 3 people working for 12 hours a day, that's 36 man hours. So they can put 50 man hours or 50 hours of labor into assembling. If you make X office shredders, you've got 5X hours going into assembly. If you make Y home shredders, you've got 2Y hours going into assembly. So the total time you spend assembling these things is 5X for the office plus 2Y for the home. And we can only put 50 man hours into that shit per day. So here's your first inequality. Second inequality is going to come from the finishing information. So each office shredder requires 8 hours of finishing. So if we look at the total finishing time. And by finishing here, they mean like polishing surfaces and painting or whatever the fuck people do with shredders to make them look nice. Each office shredder requires 8 hours of finishing. So if I make X office shredders, that's 8X hours going into finishing. Plus, each home unit requires 4 hours of finishing. So if I make Y of them, that's 4Y hours going into finishing. So this is the total amount of time it will take to finish X plus Y shredders. And I know that this has to be less than or equal to 92 because that's all the time we have to put into finishing. So the system would be 5x plus 2y is less than or equal to 50. And 8x plus 4y is less than or equal to 92. And that's it. And with that, we are just about out of time. We have 1 minute and 20 seconds left. Is there anything burning in your guys' brain that you'd like to ask or talk about in this last minute and a half or so? Okay, so remember, show up on time Thursday. Make sure you get in here. We can get the exam started, get everything rolling. Make sure your phone is charged. Make sure your browser, Chrome, is up to date and has HonorLock installed. Make sure you have paper and pencils and your graphing calculator, right? We will want all of those things. That's really it from me, gang. I think you guys all know the drill pretty well at this point. If you have any questions, of course, you can come talk to me in office hours. You can send me a Canvas message, anything like that. I did see a number of emails regarding homework and quizzes. I just haven't gotten to them yet. So if there's something really burning there that you want to talk about, come into my office hour today. It starts at 11. Otherwise, I'll try to get through those and send you messages back later today. That's it for me. Study hard. Let's make sure this test goes well, and we can move into the final with a lot of confidence. Take care, guys.